Right now, there are many dull, dirty and dangerous jobs that people have to perform. What if in the future they could be performed by robots? We really think it depends on the success of artificial intelligence.
What we wanted to do was find a way of bringing intelligence into the real world. So React Robotics is aiming to build robotics body for the artificial revolution that we've all seen coming. DogBot is about opening the way to robots that really understand the world and interact with it.
The robot has 12 axes, so 3 axes on each leg. It can walk, it can trot, go out with sensors on it of various types. So it could be 3D scanning the space, but it could also have thermal cameras and be detecting gases with spectral cameras. It's predominantly 3D printed. We're using Autodesk Fusion 360, so we can very quickly design something, test it, print a new part overnight and retest that part. This allows us to manufacture much less components than if we use conventional methods. So we can consolidate multiple functions into single parts, and therefore it's very quick to build this robot.
Lenovo's ThinkPad P1 has been hugely helpful in our product development process. The full CAD model of the robot is actually quite big and complicated. To keep the tool fluid and responsive, you actually need quite a lot of compute power, and that's why having a powerful workstation is essential for our workflow.
It's really important that we work with partners like Lenovo. They share our vision for really taking technology out into the world. We have a very open ecosystem, and we think that the more people that have access to that ecosystem, the faster the capabilities of the robot will develop.
In terms of research, the most fascinating problem is how to create an algorithm that can learn to learn.
In making a robot that can deal with the real world, there's a huge amount of data that you need to process. In fact, one of the things we had to do in the latest generation of robots is update from CAN bus to EtherCAT, so that we have 100 megabit links to get the data from the joints back into the computer fast enough and with low enough latency. So we use Ubuntu Linux because we can use it from our embedded environments on our robot through to our workstations and our machine learning platform.
Building artificial intelligence for robots is actually extremely difficult, not because of the mathematics or the algorithms, but because of the high expectation level of the general public. To achieve human-level intelligence and human-level motor skills, we need the best possible hardware and the best possible computing power.
In our ThinkStation, we're using NVIDIA Quattro RTX GPUs with tensor cores to accelerate our machine learning, because the faster your graphics card, the faster you can train your algorithms, the faster you can iterate. It's a really exciting time to be in robotics and artificial intelligence. Things are happening every day which change what is possible, and with partners like Lenovo to help us along the way, who knows what we'll achieve.